Hi everyone, let's solve the equation to call three sums. So, given integer array nouns, we want to find three numbers in the array that sum up to 0, and the solution set should not contain duplicate triples. Now let's check example 1. So example 1 has 6 numbers, right? And you see one way to sum up to 0 is use 2 minus 1, 1, 2. And the other way to use 1 minus 1, 1, 0, and 1, 1. Okay, so you see this question is quite similar to the previous question called 2 sum 2, where we had to find two nouns in the array that sum up to a specific target, and the array is sorted. So the only difference between this question and the 2 sum 2 is that we have additionally a pointer. So let's say it's I pointer, which is starting at the beginning. So let me use the join here to help you understand. Okay, so let me scroll it down so I need to read more space. And you know, in 2 sum 2, we had to sort the array before run to pointer, right? So for this question, let's again sort the array before the searching part. So we sorted the array and from the smallest to largest. So you see smallest element is -4, and then we have -1, and another -1, and then we have 0, we have 1, and we have 2, right? Okay. So actually we need a string pointer here. Let me write here. Let's say this one is I pointer, so that here. Then we have let's say the left pointer will study at the next position to I pointer. Then we have right pointer study at end. Okay. Now first thing we did in 2 sum 2 is calculate the current sum. But here current sum should be the sum between numbers at I, numbers at left, and numbers at right. So let me write out current sum using different color. Okay. So current sum equal to numbers at I plus numbers at left and numbers at right. Okay. So see, currently, numbers I is -4, numbers left is -1, and numbers right is 2. And we add it all together, we found this -3. And -3 is smaller than 0, right? This means, okay, our value is too small and we have to move the left pointer to the right. So just let this pointer to the right and write that out here. Okay. When we move this pointer to this position, we found, okay, this value is same as previous, so this duplicate and we have to skip. That's why we had to move the left pointer further to the next position. So currently we have left pointer moved to here. Now numbers left is changed from -1 to 0. So let's write out here and change this one to 0. And the result should be -2, right? But you see the -2 is still smaller than 0. That's why we had to move this pointer further to the left, to the right, sorry. So just move here and to here. Okay. Now we move this position and let me recalculate again. So numbers left is now 1. So change it to 1. And the results you see it's -1, right? Okay. But you see the -1 is still smaller than 0. And we have already moved the left pointer all the way to the end before the right pointer. So there's no way we can finish this scenario using -4 as I. Okay, so let's change these 2 pointers. And we will move I to the next position to search for larger values. So I will be moved to here. Then we have the left, we initialize the next pointer to I. And right still will be initialized at the last position. Okay. Now let's recalculate current sum. You see numbers at I is -1, right? So numbers at left is -1 also, and number right is 2. You see, okay, here the current sum is 0 is actually equal to 0. So we have to return these 3 values in our result array. So you see the first element in result array is this. Okay. Now finish this, then let's check the next pair. So we're moving the left pointer to the right. Okay, move this one to the right and calculate current sum. So you see current sum here is change this one. Oh, sorry. Change this one to 0. and we found, okay, the current sign is 1 is greater than 0. This means too big, and we have to move the right pointer left. So just change the right pointer to the left position. And now you see the current sign is -1 plus 0 plus 1, right? So we write 1 here. And found, okay, current sign is again is 0 and equal to 0. That's why we had to add the current triple pairs in the result array. So you see we have -1, 0, 1, so here. Okay, then repeat all again. We found, okay, there's only these two triple pairs, and we return this entire result array should be done. Okay, now finish the explanation. Let's dive into the coding part. Okay, so first, let me write our general coding comments. So we will save more time and make less mistakes in later code. First, and we will want to leave 2 for left and right pointer. And once we run, we'll skip the duplicates. Then we will run 2.2 function, right? Okay, so just write it here and finally return the result. Okay, here's general framework. Let's dive into the coding part. Okay, so the first thing to consider is to initialize empty result array so we can restore our triple pairs in the result. And we also want to initialize the length, right? So using the L. And the next thing to sort is array. So use the number.sort. And after that, let's run the I pointer starting at the beginning and all the way to the end. We want to leave 2 space for the left pointer and right pointer, so it will be L minus 2. Okay. Now we finish the I pointer. Let's skip the duplicates. You found okay, numbers I, so let's say I greater than 0, and numbers I is equal to numbers I minus 1. If that the case, we want to continue to the next number to skip the duplicates. Okay, now finish the first pointer. Let's think about the other 2 pointer, which is similar to the 2.2 question. So for 2.2 question, we need a left pointer at 0, but here we need a left pointer initialized I plus 1 because it should be the next pointer to I. And right pointer should be same is L minus 1, indicating, okay, it's the last element in this array. Okay, while left is smaller than right, this means these 2 pointers are not intersect each other. The first thing we want to do is calculate the current sign, right? And the second thing we want to check, okay, is the current sign small? If small, we have to move the left pointer right. And if large, we want to move the right pointer left. If match, we want to append the result. Okay. And finally, let's write code out. So you see the current sign numbers at I plus numbers at left, numbers at right. But okay, current sign is smaller than 0. This means, okay, it's too small, and we need to move the left pointer right. Otherwise, the current sign is greater than 0. Then move the right pointer left. Otherwise, we want to append the current triple pair to result. So we have numbers I here, numbers left here, right? And we have numbers right here. Okay, now append results, we'll keep increment the left pointer to find the next triple pair, right? Okay. But here's another question. So let me use the coding comment here. What if I pointer as -1 and maybe the left pointer had double 0? So let's say our left pointer here right at this 0. And again, that's similar for the I pointer, which had to skip the duplicates for left pointer. We also want to skip the duplicates, right? So we to consider additional condition. While left are smaller than right means the 2-pointer search is still valid and the numbers left are equal to numbers left plus 1. So if that case we have encountered the duplicates in left, we have to increment the left pointer to skip the duplicate. Okay, I hope it makes sense. Now, we finish all this. The final thing to return the result array. Okay, let's take a quick look at this code to see if there are typos, and we'll submit the result. Okay, so let's submit the result to see it works. Okay, you see the time capacity memory usage of this solution is quite efficient, right? And although the coding is a little bit long, I think the logic is very easy to understand, especially if you have done the previous question 2 pointers too. Okay, you like this solution, please subscribe to my channel, and I'll see you next time. Thank you.